I'm Charles, and I'm on a mission to find what's inside everything. To help me get my answers, I have an industrial CT scanner. It takes a whole bunch of X-ray images from all around a subject, and then builds a 3D model revealing every internal detail. Today, we're looking inside the two most common cordless tools, a drill and an impact driver. I want to know what separates these two machines, so let's scan them. You know the drill. Pull the trigger, and the chuck spins. Secure a tool in the chuck, and it'll spin the tool along with it. Both of these tools do more or less that. But this is not a drill. This is an impact driver. It produces very high impulses of torque using a spring-loaded hammer mechanism, letting it screw screws and fasten fasteners faster than a similarly sized drill does. So if this tool can twist, turn, and tighten faster than this bigger, heavier, and more expensive one can, what's the difference? So what functionally separates these two things? You have the different styles of chuck, you have different gearboxes. The drill has an adjustable speed gearbox, speed 1 and speed 2, and a limited torque clutch, as well as a hammer mode. And this has none of that. It has a single speed gearbox, and then it has the actual impact driver thing. But even beyond that, there's differences in how these control their motors. These don't have the same electronics inside. Let's take a look at that. Over here on our impact driver, we can see our circuit board, and we can see it very clearly, which is nice. And on our drill, likewise, we can see it very clearly, and we can clearly see that something is different. There is way more silicon on the drill than on the impact driver. Each of these little packages here is a transistor. And on our impact driver, we have 6. Appear to be in a D-pack transistor package, and these appear to be in a direct bonded die package. So the drill is built in a way that should be able to handle just a whole whack load more current. And more current in the same motor means more torque. And similarly, we can actually see that there is a heat sink. See these fins? That's a heat sink that's attached to the back of the circuit board in the drill. The impact driver doesn't have any heat sinking. It's just assuming that you'll never be able to get it hot enough that you'll need an active solution to draw heat away from those chips. Really surprising, actually. I wonder if there's a different rate of failure for these, and if it's lower or higher on the electronics than for the drill. Digging a little deeper here, we can see the actual integrated circuit that's doing the motor control on this device. Meanwhile, on our drill, we have that on the backside, and it kind of looks like these are the same package, and I might even hazard a guess they are the same exact chip. The triggers on both the drill and the impact are functionally identical. And in fact, I'll go a step further, they're identical. Why not? It's the same brand, why wouldn't they reuse those parts? But they both pull double duty, not only as an analog slider being sent to the motor controller, but a power switch. You see, they actually have these pretty sizable contacts going into them. Sorry, both here and here on the impact, and here on the drill. That's fully interrupting all of the power going to the motor controller. So these things can't be made to work if that switch fails, which not an inappropriate failure mode for something like this. Let's actually dig into what makes the impact driver an impacting driver. This is going to be a dog of a thing to explain. The clearest functional part that we can make out here in the spring-loaded hammer mechanism is, of course, a spring. Now, what the heck is that doing? Now, this spring is coupling the output of our gearbox to the input of our hammer mechanism. The hammer is what's doing the spinning. And so, what we would see here, we have our hammer. This is going to get spun up by the motor, and most of the time, it's going to be directly dogging against our output shaft. And our output shaft is the anvil, and it's actually right here and is the same piece of metal as the chuck, what's driving our hexagonally shanked, I don't know, Phillips screw bit. Eventually, we're going to run out of torque. We're going to reach the point where our motor cannot actually supply enough torque to keep advancing that screw into, say, a 2x4. That is where the magic of the impact driver starts to happen. Because we're driving through this spring. When that output stops spinning, we're also going to find that the interface between our hammer and our anvil is slanted. Right there. There's the slant. It's slanted so that under the building torque delivered by the spring getting twisted and twisted and twisted further, it will actually start to slip backwards. So this hammer
will go from just being torqued by the spring to also being pushed forward by the spring as it gets pushed backward off this ramp and compresses the spring rearward. At a certain point, our hammer is actually going to spring back far enough that it clears the anvil. And at that point, well, it can spin freely, except only for half a rotation, because half a rotation later, it's going to re-encounter the anvil, because it's getting pushed forward by that spring, drops into the free space around the anvil, and slams into the anvil. And in doing so, it's going to deliver a massive impulse of torque into the output shaft. And when you do that, well, you've advanced your screw 1/10 of a turn. It's not much. But if you can do that 2,700 times a minute, well then you can just right your way through a 2x4. Because you get this very efficient conversion of energy into torque, you don't actually need a super powerful motor, which is why they're able to get away with this much more lightweight electronics on the circuit board. That is the magic of the impact driver. A drill can get similar driving speeds in light materials without any of this impacting. It just produces torque and drives through, especially if you drop it into, the low gear. Question is, how is it getting torque, like continuous torque, not this repeated impacting torque? Now there's even more metal in this scan, so it is even harder to interpret. Because we've used these tools before, we do know where to find the things we're looking for. We should actually expect to be finding 2 gear reductions in here. So one of these will be our high-speed gearbox, and it will be our low-speed gearbox. And we can actually see over here at the back end, we have our first set of gears. Here is our first stage planetary reduction, and that's going to be taking the motor RPM and cutting it down by about 6 to 1, 8 to 1. Outer ring gear, it's a little hazy. There's a lot of metal in here, so it's kind of difficult to get a good scan. Here we can actually see the profile, just barely, of the outer ring gear for the second stage. And critically, you'll notice it has these teeth on the outside. Those aren't gear teeth. Those are tabs that are either going to let you engage that ring gear with the chassis of the drill, or let it spin freely from the chassis of the drill, while on the inside locking it to the planet carrier of the second stage reduction. Because of that, you can either swing this ring backwards and have a 2-stage reduction, or swing it forward and have a single-stage reduction, which will be way faster, but less torque. So somewhere around here, we should be able to find more gears. There's a gear interacting there and there, but it's pretty hazy, I'm not gonna lie. Now, when you have both of these gear stages engaged and reducing it by, 64 to 1 or something like that, you'll get an immense amount of consistent torque coming from the motor into the chuck. And critically, we also have that beefier drive electronics for the motor, which means we can develop more torque at the shaft, and we're multiplying it more than we did in the impact driver. So with all that, you should be able to get substantially more torque and just drive screws straight on through, if not perhaps quite as fast as you get them to go with the impacting driver. So that is the difference, at its core, between a drill and an impact driver. If you enjoyed this video, make sure to leave us a like. And if you want to see inside of something, leave a comment with your suggestion. If you want to support the channel, share this video with a friend, or check out hacksmith.store. And if you want to see inside of everything, get subscribed.